Welcome back to my YouTube channel. So we are going to be looking at we're going to be diving through the main contents of Fourier series. So on our previous video we've just been talking about what we need to know of the surface, basically the surface of Fourier series. So now I want to look at Fourier series itself and maybe one or two examples. So now let's go. So we have that if a function fx is defined on the interval minus pi, from minus pi to pi. Remember I said on our last video, like I said, most Fourier series limits ranges from minus pi to pi or 0 to 2 pi, so that it gives us a range of period of 2 pi. So if I say minus pi to if I say pi minus pi, it gives me 2 pi. So in Fourier series we make use of the period of 2 pi. So, which is basically what this is also saying. Then this right here, if it satisfies the condition of in which the range comes from minus pi to pi, then we can apply Fourier series and expand it with this formula. So this here is called Fourier expansion of fx. So having said that, where a subscript n from this right here is equal to 1 over pi, integral coming from minus pi to pi, fx cos nx, and bn is equals to 1 over pi, integral coming from minus pi to pi, of fx sine nx. So all these have their respective way in which they were proved. But if I can prove it, but if I decide to prove it, it's going to take our time. So I want us to dive into examples on Fourier series so you see how to apply it. So the issue is how to apply the formula. So maybe on later I'll drop a video on how they are proved. So these two siblings right here are called Fourier coefficients. They are called Fourier coefficients. So now, having got that out of the way, so now let's I believe we can take an example on let's take an example, then you see how we can solve this. So basically, before we go there, let me drop a hint. So you'll be given a function fx and asked to find the Fourier series of that function. So the best way to do it, the first thing you need to do is to calculate, let's call it hint. So the first thing you need to do is to calculate your a0. So we find a0. So after finding a0, we find a subscript n, and the third thing we find b subscript n. So after getting these values here, all we need to do is just impose it back into the formula. That is that, we're done. So now let's take an example. So now let's look at this example we have in front of us. Now I'm going to give you let's say something like a warning, or not like a warning, just like let me call it a hint too. Just know that all Fourier series calculations are always going to be long. So if you're expecting a short solution, blah blah blah, we are done, that's it. Now all Fourier series calculations are always long. So I want you to buckle up and let's go for a ride. So to solve this, now if you remember our previous video on periodic function, I really explained how to interpret this. I explained it in detail, so I advise you to go and watch the video if you have not watched it. And so now let's go on. So we have, if we said find the Fourier series for the function, and shown, consider one cycle between minus pi and pi, meaning that between one oscillation we're having a period of 2 pi. That's what it means. So and we're having this. So now let's just assume, let's just plot something like the graph. So let's plot the graph. So let's draw my coordinate. So it's not a must you might be plotting. You must plot the graph. It's only when the question comes in this way. So it's understandable to plot the graph before solving. So it says that for fx equal to 0, that is for y is equal to 0. Remember, this is fx, which is also y, and this is my x, right? It says for y equal to 0, it ranges from minus pi to pi over 2. Remember minus pi, remember minus 1 over 2 is greater than minus pi. So minus pi comes here, minus, let this be minus 1 over 2, right? So it says, and let this be 0. So it says between minus pi, right, and pi over 2, y is 0. So let's draw a thick line here. Let's draw a line here, right? So it says f is equals to 4 between minus pi over 2 and pi over 2. So this is 0. This can be pi over 2 and this can be pi, right? So between minus pi and between minus pi over 2 and pi over 2, fx is equal to 4. So this is fx and this is 4, right? So since it's a constant value which is 4, then we assume that it is going to be a straight line. So it goes like this. Is equal to 4 and is also equal to 4, right? So you can just draw a straight line joining the two lines, right? Then we said between x is equal to pi over 2 and pi, f is 0. So this is pi over 2 and this is pi, so it comes again. So then this is what? 0. So this we have successfully interpreted what we have in front of us. So now let's go down to solving or deriving the series in which we are asked to derive. So given the formula for Fourier series, which is this, right? Fx is equal to a0 divided by 2 and blah 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 blah. So like I said, the first thing for us to do is to calculate my a0. So now let's find the a0. #1 a0, right? So remember that since an is equal to 1 over pi, integral coming from minus pi to pi, of fx cos nx, right, dx, then a0 from this can be gotten as a0 is equal to 1 over pi, integral coming from minus pi to pi, fx cos 0x dx. And if you can remember, cos 0 is 1. So which means my a0 for every Fourier series question we'll be solving is going to be 1 over pi coming from minus pi to pi of fx dx. Now this formula can change when you are solving even function and odd function. So which we'll still get to that phase. Let's just work on how to solve most simple Fourier series problem. So now we have our a0. So now let's calculate the value for my a0. So now, since we are having 3 values of fx, remember we are having 3 values of x. We are having 0, we are having 4, and we are having 0. So we are going to make use of all the values of fx. Now if you can remember, the range of value, remember the question says from minus pi to pi. The range of value has been splitted in 3 ways. Minus pi to pi over 2, from pi over 2 to pi, from minus pi to minus pi over 2, from minus pi over 2 to pi over 2, and from minus pi over 2 back to pi. So we're going to be making use of that split. We're going to be splitting up also this integral we have here into these 3 ways we have given in the question. So it goes like this. So a0 is equal to 1 over pi. Now instead of me using minus pi to pi, since it has already been splitted in 3 ways, and we're having 3 values of fx, so we're going to be using the range for the associated value of fx. So remember what is next is my integral, right, and my function of x. So since let's start with 0. Since we're having a function of x of 0 and it makes use of this range, so let's use that range. So it makes use of minus pi to minus pi over 2 of 0 dx, right? Then let's call this, let's put a bracket there. So plus our next value of fx is what? 4, right? So which makes use of range of minus pi over 2 to pi over 2. So we'll be having integral coming from minus pi over 2 to pi over 2 of 4 dx, right? Plus our last values of x, which is 0, right? Ranging from pi over 2 to pi. So plus integral coming from pi over 2, right, to pi of 0 dx, right? So we know very well that integral of 0 is 0. So all this you can call this 0. And we can also call this 0. So we are left with just this. We are left with a0 is equal to 1 over pi, right? Integral coming from minus pi over 2 pi over 2 of 4 dx. So remember, we integrate before we apply our limit. So integrating 4 dx will be left with just 4x, right? Then applying my limit of minus pi over 2 to pi over 2. Don't forget your 1 over pi, which is this. So applying my limit, I'll be having 1 over pi, open bracket 4, applying this first limit, so this is pi over 2, right, minus 4, applying my second limit, this is minus pi over 2. So this gives me 1 over pi divided by 2 in 1, 2 in 4 is 2, so this gives me 2 pi minus 2 in 1, 2 in 4 is 2, this gives me minus 2 times minus pi. So it gives me 1 over pi, open bracket 2 pi plus 2 pi, and this gives me 4 pi divided by pi, which is equal to pi. Sorry, which is equal to 4. So that is the value of my A naught. So my A naught is equal to 4, which we have gotten that out of the way. So the next thing we do now is to find my A naught, my A subscript n. Sorry, my A subscript n. So we know that A subscript n is equal to 1 over pi. It's going to come from minus pi over pi fx cos nx. So making use of this formula, we use the same process we used to solving A naught. So this is 1 over pi. Now, since we're having 3 values of x, 0, 4, and 0, for the first 0, the range comes from minus pi to minus pi over 2 for 0. And since it's multiplying cos nx, so we put it cos nx plus, use the same range from minus pi over 2 to pi over 2. And instead is 4, fx is 4. Then multiplying by cos nx plus integral come from pi over 2 to pi of 0 and multiplying nx. So we've expanded this. Then from the looks of this is definitely 0. 0 times this is 0, so this is also definitely 0. So we are left with just this. So my A subscript n now is equal to 1 over pi, right? Integral comes from minus pi over 2 to pi over 2. Then this is 4 cos nx dx. Right. So we're going to be evaluating this. First thing we need to do now is to take the constant 4 to the back of the integral. So we are left with 4 over pi. Integral coming from minus pi over 2 to pi over 2 cos nx dx. So now we integrate before we apply our limit. So integrating before our limit is being applied. So integrating cos nx, which will give me sine nx, now dividing through by the function attached to x, which is dividing by n. Then applying my limit, which is minus pi over 2 to pi over 2. Right. So applying my limit, anyway I see x, I put pi over 2. So this is 4 pi over, so it's 4 over pi divided by, open bracket, sine pi over 2n divided by n minus sine minus pi over 2 n divided by n. Right. So since pi over 2 is 90, right? And we know that sine 90 is what? So we having done this, so we know that from our trigonometric function, we know that sine of x is equal to minus sine minus x. It goes to minus sine of minus x, right? So since we're having sine of pi over 2 here and we're having minus sine of pi over 2 here, this here can be equal to the positive of this. This is a rule in our trigonometric function. So the sine of a function, or the sign of a value, is equal to the minus sign of the negative value. So we apply it here. So sine of pi over 2 is equal to, so sine of pi over 2 n is equal to minus sine of pi over 2 of minus sine of minus pi over 2n, which is what we have here. So replacing this with this, we have 4 over pi, right? Open bracket, sine pi over 2n divided by n plus sine pi over 2n divided by n. Right. So this are equal, x plus x is 2x, so this plus this is 2 sine pi over 2n divided by n. Right. So we have our function, so 2 times 4, which is 8 over pi sine pi over 2n divided by n. So this is the value for my a naught. So now if I decide to impute values of n, when I decide to impute values of n in this, if I say let n be equal to 1, we will know that sine pi over 2, which is sine 90, is 1, and this is 1, so which we'll be having 8 over pi. So if I say when n equal to 1, I have 8 over pi, right? So when n equal to 2, let's try when n equal to 2, which I have sine 180, and sine 180 is 0. So if I try let n equal to be 3, let n equals to 3, I'll have this to be 1. If I say let n equal to 4, I'll have it to be 0. So for my odd functions like n equal to 1, 3, and 5, my a naught, a subscript n, will be 8 over pi n, because the sign of this will be 0 for odd function. But for even function, my an will be what? A subscript n will be 0. So we have to take note of this. So now, having done that, let's calculate for my b subscript n. So calculate for b subscript n. We know that b subscript n is equal to 1 over pi, integral coming from minus pi to pi, of fx sine. B subscript n has a sine function of nx dx, but a subscript n has a cosine function. So following the same process, we having that my bn is equal to 1 over pi, and since we're having 3 functions of x from the question, we're having 0, 4, and 0, so we'll make use of the 0 first, and the range it is having, so this is from, it said it was having a range of minus pi over 2, so it was having a range of minus pi to minus pi over 2 for the first 0. Then since it's multiplying sine function, let's multiply it by the sine function of n, x, plus it was having a range of minus pi over 2 to pi over 2 for 4, multiply it by the function s. Remember, this is my fx, my function of x. So any value I put here, I'll have to multiply by the value that was already present, which is my sine nx. So this is sine nx dx, plus integral coming from pi over 2 to pi for 0, then also multiplied by sine nx dx. So from the looks of it, we all know that this is 0 and also this is 0, right? So we'll be left with 1 over pi, integral coming from minus pi over 2 to pi over 2 of 4 sine nx dx. So we take the constant 4 to the back of the integral sign. So we'll be left with 4 over pi, open bracket, integral coming from minus pi over 2 to pi over 2 of sine nx dx. So then we integrate. So we'll be having integrate before applying our limit. So integrating sine nx, we'll be having minus cos nx divided by n. That's the integral of sine nx. Then apply my limit of from minus pi over 2 to pi over 2 of 4 over pi. So imputing my limits in, we'll be left with 4 over pi minus cos n times pi over 2 divided by n minus cos n minus pi over 2 divided by n, closing the bracket. So multiplying through by my minus sign, so now I know how to simplify it. So I'll be having 4 over pi minus cos n pi over 2 divided by n plus cos n minus pi over 2 over n. So there's a rule in also in trigonometric function that says cosine of x is equal to cosine of minus x. Remember, for an we said that sine of x is equal to minus sine of minus x. But in this one, in this case, is different for the cosine. So we can just apply this rule here. So since we know that cosine of x is equal to cosine of minus x, then we can apply it here. So we'll be having that, meaning that cosine of pi over 2n will be equal to the cosine of minus pi over 2n. So we apply it here. So applying it there, we'll be having 4 over pi. Anyway, I see cos of pi over 2n, or anyway I see cos of minus pi over 2n, I replace it with this. So anyway I see this, I replace it with this. So we'll be having minus cos n pi over 2n. So I'm replacing cos pi over 2n with this. So this is plus cos pi over 2n divided by n. So since these are equal, so this gives me 0. So technically my b subscript n is equal to 0. So having done that, having gotten our values, then we can just put it back into the Fourier series expansion formula and get our series. So remember the expansion formula goes like this. Function of fx is equal to a naught divided by 2 plus plus the summation of n to 1 to infinity of a subscript n cos nx plus b subscript n sin nx. So this is the expansion formula for Fourier series. So since we've gotten our a naught, remember our a naught was what? Remember we got our a naught to be 4, right? Or a naught to be 4. Then we got our a subscript n to be 8 over pi sine pi over 2n over n. And we said when n is equal to the odd, when n is equal to odd values, an is equal to this. When n is equal to even values, an is 0. So basically the value of an was this, right? So we substitute. So substituting our formula of values, we got a substitute 0 to be 4, and we got a substitute n to be 8 over pi sine pi over 2n over n. So substituting it, now we having fx is equal to 4 over 2, right? Plus, now this summation stands because this summation, meaning that it's going to give us a series from here on. So starting from n equal to 1, if I put 1 here and put 1 here, let me just define it in a way you can understand. So this is summation of n equal to 1 or to infinity of 8 over pi sine pi over 2n divided by n. Since bn is equal to 0, so we don't have to include it. So don't remember that it's multiplying cos nx, so multiplying cos nx. So this is the expansion formula for my function of x we are to find. So now let's find our series. So let's expand it. So when n equals to 1, so we'll be having 2 here. N equals to 1, so this is when n equals to 1, we're having sin 90, and sin 90 is 1, so we'll be having 1 here also. So this is 8 over pi times cos 1, cos 1x or cos x, plus when n equals to 2, when n equals to 2 here, must put in 2 here. So 2 times 2 is 1, 2 divided by 2 is 1. This is sin 180, and sin 180 is 0. So if this is 0, this is also 0. So we have 0 plus and 8. So let's put here when n equals to 3. So we're having 3 times 90, which is 270, and sin 270 is also 1. Sorry, sin 270 is minus 1. So we'll be having my minus 1 or at the numerator here. So we'll be having multiplied by minus 1. So divided by 8. And we said when n is equal to 3, right? So this is 3. And when n is equal to 3, so this is cos 3x. Right. Plus, when n is equal to 4, remember I said on our previous video that when we are having even values, this will be giving us 0. So when n is equal to 4 is also going to give us 0. Now when n is equal to 5, 5 times 90 gives me what? 450, right? And sin 450 is 1. So this numerator gives me 1, right? So this is 8 over pi. And since we said when n is equal to 4, so this is times 4. Cos when n is equal to 4, so this is 4x. So that goes on and on and on and on. So writing the series we have in front of us, so fx now is equal to 2 plus, now factorizing 8 over pi out, so this is 8 over pi open bracket cos x minus, so this is 1 over 3, right? This has a denominator of 3. This is minus 1 over 3 cos x to cos 3x plus, since this is having a numerator of 4, since we only factor out 8 over pi out, so we left with 1 over 4 here. So this is 1 over 4 cos 4x, and it goes on and on. So this is the Fourier expansion for the function of x we were given on our question. So in our next video we'll be looking at another example on how to solve simple Fourier series question before we go to odd and even function. So see you guys on the next video. Thank you for watching. Please hit the subscribe button. It will take you nothing less than 1 second to do it. Peace.